Hi guys, I have this question that I want to share with you. Here is the question from November 2020, paper 2. So I want to share this question with you. The question 2A is trig identities. We want to prove trig identities. So the question said, prove the identity square root of 1 minus sine theta over 1 plus sine theta is identical to, so this sign is not equal, but it's identical to sec theta minus tan theta, which is 3 marks. So in order to prove this identity, you can choose the simplest side and simplify it so that the left hand side should be equal to right hand side. So to make this question simple, let's take the left hand side so that it will be equal to right hand side. So left hand side is given by root 1 minus sin theta over 1 plus sin theta. So which is root of 1 minus sin theta over 1 plus sin theta. So we want to prove this identity, so that it will be equal to the identity this one. Right. So in order to prove this identity, which involve the square root and the fraction inside the square root, you have to partialize. You have to partialize the first. You have to partialize first. So or you have to simplify by multiplying the value inside the square root by the conjugate of the denominator. So what the denominator is 1 plus sin theta. The denominator is 1 plus sin theta, and the numerator is 1 minus sin theta. So we have to multiply by the conjugate of the denominator. So which is equal to root of 1 minus sin theta over 1 plus sin theta. So we have to multiply both sides, the upper and the lower, by the conjugate. The conjugate of this one, we have to change the sign of this value, of this 1 plus sin theta. So by changing the sign of this sign positive, it becomes negative. So the conjugate becomes 1 minus sin theta. Then we also have to multiply by the conjugate on the numerator, so which is 1 minus sin theta, which is equals to, right, remember 1 minus sin theta multiplying 1 minus sin theta, which is equal to root of 1 minus sin theta all squared over, then we have to multiply this one, these two, but we said we have to multiply by the conjugate. But the conjugate and the real this value, real value, and the conjugate, if you multiply them, it's like a different two squares, so which is 1 minus sin squared theta, but the square root remains. So now we have a root of 1 minus sin theta all squared over 1 minus sin squared theta, right? So for this stage, we have to roll code the identity of this expression 1 minus sin squared theta. What's the identity of 1 minus sin squared theta? So the identity of 1 minus sin squared theta, right? So which is we have to roll call the identity of this one is sine squared theta plus sine plus cos squared theta is equals to 1. So we have to make a sine substitute formula, which means the identity of sine squared theta is 1 minus sine squared theta. We have to make cos the subject formula here, cos squared theta. So making cos squared theta, which is cos squared theta is equals to 1 minus sine squared theta. So the identity of 1 minus sine squared theta is cos squared theta. So we have to write the identity of 1 minus sine squared theta on the denominator. So which is root of 1 minus sine squared theta 1 minus sine theta all squared over the identity of 1 minus sine squared theta is cos squared theta. Right. For now, let's deliver the root on the numerator and on the denominator, which is root of 1 minus sine squared theta over root of cos squared theta, which is equal to the square root of 1 minus sine squared theta. The square root of 1 minus sine squared theta is now the square root of 1 minus sine theta all squared. I mean 1 minus sine theta all squared. The root of that value is 1 minus sine theta over the root of the square root of cos squared theta, which is cos theta. So let's now deliver the denominator on each and every value. So 1 over cos theta minus sine theta over cos theta. But we already know that 1 over cos theta is the identity of sec theta. Is the identity of sec theta minus the identity of sine theta over cos theta, the identity of tan theta. So since left hand side is equals to right hand side, left hand side is equals to right hand side. Then we have to write shown. Since the question said prove that, we have to write shown. We can write proved. So this is how to deal with the identities involving the square roots. So thank you guys for being together for this lesson. Don't forget to subscribe, like, comment, and share for more videos.